The cooling system is a vital component of generator operation. As we mentioned in the last segment, the amount of power which a generator can supply is limited by the temperature rise of the windings. Therefore, the more efficient the cooling system, the greater the load that can be placed on the generator. For small turbine generator installations, air cooling is employed, usually open cycle. The air is actually circulated through the generator by fans, which are fitted at each end of the rotor. As the rotor spins, the fans provide the force to circulate the cooling air through the rotor and stator core. Cooling ducts are often built into the rotor and stator core to allow passage of cooling air. This diagram shows a typical arrangement. Air is drawn in from atmosphere and passed through filters to remove any particles of dust or other contaminants. The air is then drawn down through silencers into the fan impeller at each end. The air is exhausted radially from each fan under pressure and is directed to follow the desired cooling path, eventually exhausting to atmosphere. In some units, silencers are fitted to the air exhaust as well as the inlet. Usually, a separate cooling system is provided for the exciter or collector rings. In this particular arrangement, a small fan impeller is fitted into the collector air inlet adjacent to the collector rings. Air is pulled in through a filter to circulate through the terminal connections and collector rings. As we can see, this system is self-contained and requires no attention from the operator other than to ensure that the filters are clean, thus allowing sufficient air to pass. The pressure drop across the filter will indicate when it needs to be replaced. On standby or peaking units, this task can easily be performed when the unit is out of service. It is produced within the generator in three ways. Current flowing in the stator winding produces heat, which is proportional to the square of the current. This is the I squared R, or copper loss. Friction between the spinning rotor and the air, or hydrogen, in the generator produces heat called windage loss. Stray induced currents in the iron core produce heat called iron loss. If the internal temperature rises too high, it will damage the insulation and put the generator out of service. For this reason, distinct limits are placed on permissible temperature rise. In order to monitor this, temperature detectors are embedded in the stator windings at the anticipated hotspots. These readings are continuously recorded and alarmed when necessary. Forced cooling is employed to keep the temperature rise as low as possible, either by hydrogen cooling or air cooling.